Okay, so energy is what makes matter move or heat up, and the international metric is the, oh boy, the joule. There we go. Power is the rate at which energy is used, and the metric for that is the watt, which is joules per second. A rate is always something, not always, but in terms of energy is something over time. A rate is always a ratio. It's basically what calculus is all about, is rates of change. So 1 watt is 1 joule per second. And then a kilowatt hour is a unit of energy, which is 3.6 million joules. Right? So let's convert weeks to hours. And so we'll do that by going, okay, let's first convert weeks to days. So 1 week is 7 days. All right, so now we're in kilowatt days. And then let's do 1 day is 24 hours. Days cancel. All right, so now we're in kilowatt hours, which is what our pricing is in terms of, right? So let's multiply this out. So you'll go ahead and hit your calculator. You'll multiply out everything in the numerator, which would be 100 times 1 times 1 times 7 times 24. Everything in the denominator, that's going to multiply out to 1,000. And then you're going to divide, right? And that comes out to 16.8, and our units are kilowatt hours. And so remember, kilowatt hours are a unit of energy. It's about 3.6 million joules. All right, so let's go. We have our 16.8 kilowatt hours. We're going to multiply that by our cost rate, which is 15 cents per hour. Sorry, per kilowatt hour. So this will get us, cancel out our kilowatt hours and put us in terms of cents. By the way, how long has it been since you've seen a cent sign? It's weird looking. All right. Anyways, multiply that out, and you're going to get 252. So 252 cents. Aiden, how much is 252 cents?
$2.52.
Oh, perfect. So finally, we're at our final answer, which is $2.52, which is how much it would cost to leave a light on for a week. All right, so how much would you save for a light, an LED bulb that provides the same amount of light with only 25 watts? Well, we could go through that whole calculation again, or we could be a little more clever about it. How much is, what fraction of 100 is 25? A quarter. Good. So then it should be a quarter of the cost, right? So a quarter of the cost, $2.52 divided by 4 is 63. So a 25 watt light bulb would only cost 63 cents per week. Now they ask us about how much would we save in a year. So both of these are costs per week. How many weeks in a year? 52. All right, so multiply both of these by 52. So $2.52 times 52. All right, so it's going to cost you $131.04 per year for the 100-watt light bulb, and it's going to cost $32.76 per year for the 25-watt light bulb. So subtracting those, hey, that's $98.25 per year. You could take yourself. That's a nice Olive Garden dinner right there, guys. Just upgrade to those LEDs. All right, any questions on that first example? Give me a green check if you're good. So density and concentration. Density describes compactness or crowding, and it's given in mass per unit volume. So that would be like grams per cubic centimeter. Population density is given by the number of people per unit area, so like people per square mile. And then information density is given in units of mass per unit volume, which is like gigabytes per square inch. You don't have to memorize these. This is just some general definitions. You do want to know that the definition of density is that it describes compactness or crowding. All right, and then concentration describes the amount of one substance mixed with another. So, like air pollutant would be in pollutant per million molecules of air, or parts per million, ppm. And we talked about this one. We did a little intro at the beginning of this unit about blood alcohol content. BAC is the concentration of alcohol in a person's body in grams per 100 millimeters of blood. I was thinking about that one the other day. I was like, wow. That must have been interesting for parents walking through rooms as we were going over what would happen or how much of a beer it would take to be legally drunk if the alcohol was absorbed immediately into the bloodstream. But it's science. We're just doing science and math. Naomi, is there a catch for using an LED? No, they're just a more efficient light bulb. They're a little bit more expensive, but I think they've gotten cheaper as the technology has become more widespread. But they're still a little more expensive than like a standard light bulb, but they also last. They last like 10 years. So there really isn't a catch. You should switch to LED. All right. So we'll do a little bit less of a, what's the word I'm looking for? Not controversial, but scandalous example than the blood alcohol content one. We'll do one about a dose of medicine for a child with an ear infection. So a child weighing 15 kilograms has a bacterial ear infection, and a physician orders treatment with amoxicillin at a dosage based on 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours. So how much amoxicillin should be prescribed every 12 hours? All right. That's a lot, but this isn't too bad, so just try and follow along with me. So let's do this. We're going to do 12-hour dose. And so what we're going to, again, we're just going to think about what we want our answer to be in terms of, right? So the dosage, the medicine is given in milligrams. So what we're looking for is a final answer in milligrams. All right, well, they tell us that it should be 30 milligrams per kilogram of body weight per day. But we're only looking for a half-day dose, right? So we're going to divide that by 2. So what I'm going to say is that this indicates 15 milligrams per kilogram per day. Or per half day, rather. So let's start with that. We know that we want the dose to be every 12 hours, 15 milligrams per 1 kilogram. And then all we have to do is take the child's weight into account, which is 15 kilograms. Good. Kilograms cancels. This leaves me in units of milligrams, which is what I want. 15 times 15 is 225 kilograms. So our 12-hour dose is, oh, I'm sorry, not kilograms. That is a lot of medicine. Milligrams. We're not trying to kill the child, just milligrams of amoxicillin. All right. If the medicine is to be taken in a liquid suspension with a concentration of 25 milligrams per milliliter, how much should the child take every 12 hours? So we already know that our 12-hour dose is 225 milligrams. So we're going to start with that. We're going to keep in mind what we want as an answer. So we're looking for how much liquid should they take. So that's going to be an answer in milliliters. So we're going to keep that in mind. I'm trying to get to milliliters. And they tell us that it's 25 milligrams per 1 milliliter. Well, I'm trying to cancel out milligrams, so instead I'm going to multiply by 1 milliliter per 25 milligrams, right? And that way I'm canceling out milligrams and I'm left in units of milliliters. So this should give me the correct dosage of liquid. So it's just 225 divided by 25, which is 9. So every 12 hours, they'll take 9 milliliters of the liquid suspended amoxicillin. All right.